I know the next guest, not necessarily from lots of magic tricks, although I know he knows some. I know because first of all, he trained as a teacher at the same place I did. Incidentally, also the same place that Zoe Griffiths, who you saw earlier, trained as a teacher. And so we share a sort of teaching history, which I'm very proud of. And he is one of my favorite examples of someone who takes a mathematical idea, which I've known about, and then he actually does it. He actually goes and makes the thing that I've known was possible, and no one else had the guts to actually go and do. And this person, if they're ready to turn their camera on, can I introduce to you Matt Scroggs? Are you there, Matt?
Yes, but my camera's not turning on. I'm on the wrong side.
Excellent. Well, Matt is going to be a disembodied voice while he's working out his camera. Do you want me to provide commentary on your camera working out, or shall I just...
you can guess what might be wrong. How on earth?
When we've been practicing all these 24-hour maths segments, and people's cameras which work fine, and you keep running these things for hours, and then suddenly they stop working until you find the magic button. And now we have Mr. Scroggs. Welcome.
Hello, Ben. How are you doing?
I presume you can hear me, otherwise you wouldn't be saying the words in the appropriate place.
Yes, I can hear you.
You can probably see how much I'm sitting here cooking and sweating in my sort of Halloween stuffy room, but you are doing all right. Have you been watching the show so far?
Yeah, I've been watching the whole thing. It's been really good so far. I really liked in Tom's bit how we got a live aha moment on camera.
Yeah.
Like it's the best bit of doing maths is getting an aha moment, and we had one live.
And it normally happens in a closed room, right? You know, you're on your own and you've been spending hours beating your head against a brick wall of frustration, and then, and we saw it. Yeah, there was a good moment.
That might be my highlight so far, watching that happen to someone.
So tell us a little bit more about your background before you tell us about the thing you want to show us, because I'm excited about the thing, but I don't want to give too much away. But I said you trained as a teacher. That's right?
Yeah, so I trained as a teacher. In fact, I did one of my first teaching placements in the school Zoe was teaching at.
Really?
Yeah. So me and Zoe go back surprisingly far. And I was a teacher then for 3 years. Then I left teaching to go and do a PhD at UCL. And now I'm a postdoc at Cambridge.
You're actually doing like research mathematics?
Yeah, well, research engineering officially, because I'm in the engineering department.
That still counts.
But it's my boss is a very, very mathematical engineer.
Turns out engineers need maths, however mathematical they are, they need it. Yeah. And what are you working on at the moment, if you're allowed, as long as it's not in the...
so I'm on a big project involving Rolls-Royce. So they would like to simulate a full jet engine. So currently what they do is they have a really big wind tunnel. They build them.
They build real engines, don't they? I mean...
Yes, but if they're designing a new engine, they will get a wind tunnel. They will build a really expensive engine, try it. Oh, that's rubbish. Throw it away. Build another one and keep going like that.
Okay.
But they'd like to be able to like fully simulate this on a computer. So we're looking at computer methods for simulating these kind of things better.
So that you don't have the expense of building a whole engine.
Yeah.
Gotcha. Power of modeling right there. Okay. So are you getting to model a real jet engine in computer programming?
That's the aim. Obviously we've not got that far yet. We're currently doing like lots of spheres and cubes and smaller things and building upwards, but we're building the machinery that will eventually go on to be applicable to jet engines. Lovely.
Right. Well, I might come back to more of your mathematical history in a bit, but I know that you built a thing that does a thing. That's about as vague as I'm going to stay. Can you explain the thing?
So for my magic trick today, I kind of have a question for you first.
Okay.
Who do you think is smarter, the mathematician Ben Sparks or a pile of matchboxes?
At this stage of the night, it's probably the same answer as I'd give at any other stage of the day. It's probably the matchboxes, but that's because I know what you've been doing to matchboxes. And so if I say matchboxes, I hope that's not a spoiler for anyone else.
No, because I'm now going to reveal the matchboxes. So you have to bear with me while I just rotate myself to the other side of the table where you can see the matchboxes are currently sitting.
I can see a graph. I can see some matchboxes covered in some diagrams and a sort of graphic in the top right of the screen.
So the graphic. So what we're going to do is you are going to play a game against these matchboxes.
A game.
And I am going to do the magic trick. Is going to be the matchboxes are going to be beating you at this game. Do you know the game NIM?
I do, and I know also that the game I associated with you in Matchboxes was Noughts and Crosses, and I can see a lot of people in the YouTube chat had thought something similar. But this is not. This is the
Yeah.
game
So actually,
Nim.
if I
So
slide the camera, you might see something behind there that
oh,
will be
hello.
later to do with noughts and crosses. But first, yeah. So I've got the game Nim. So the idea of the game Nim, this is what you can see in the top right of the screen.
Okay.
You can see a pile of 3 purple things and then 2 piles of 2 purple things.
I'm seeing things. I'm slightly colorblind, but I guess that doesn't matter too much here.
Yes,
So I'm 3, 2, and
they're-
2. I agree.
They're all the same color, so it doesn't matter which color they are. And the idea of this game is that you and the matchbox is going to be taking these things, and the person or matchbox who takes the final thing loses the game.
Okay.
And we're going to let the matchboxes go first. So what I'm going to do first is I'm going to take this matchbox here, and you can see on the front of that matchbox there's a picture matching the current game situation.
3, 2, 2. Gotcha. Yeah.
So I'm going to shake this matchbox, and inside the matchbox, I'm looking away and taking a coloured bead. You can see there's some coloured beads in there. And
So you took one at random from there.
One at random without looking yet. I got a green bead.
Green.
And I have a key over here, which tells me which colours mean where. And green says I need to take 2 pieces from the centre column.
So because it's the second one up, it meant take 2.
Yeah, so I've done it as the bottom one is to take 1 piece, take 2 pieces, take 3 pieces.
Gotcha.
That was off camera. So I'm going to take 2 pieces from the centre column. Now it is your turn. What would you like to do?
I can see that it took 2 pieces from the middle. Remind me the rules. Am I allowed to take as many as I want, but only from one pile? Is that
as
the
many
rule?
as one, but only one from one pile. Yes, that's the version we're going for.
And reminder of the winning condition: if I take the last thing, I lose.
Yeah.
Okay. So I'm gonna just take it slow. I'm gonna take 1 from the top, from the left pile.
Good. I pressed the right button. I was worried I'd got it upside down.
It does sound like you're hitting a drum when you press those buttons. It's quite exciting.
Yeah, it's because I've got a little keyboard that's on the same table the microphone's on, so it shakes.
Ah, gotcha. Yeah.
Okay, so now I need to look through the matchboxes and find the one which matches what we've got currently.
Oh, I see. So the diagram tells you the state of the game. Is that right?
Yes. So you can see it's this one, except I've got my gap on the right rather than the middle, but it doesn't really matter what order the piles are in.
Yeah, they're just 2 piles in the end. Okay,
Yeah.
I agree.
So again, I'm going to close my eyes and take a bead.
Yeah, this is weird. So it's not you playing me. It's just the beads telling us what to do.
Yeah, the beads are telling us what to do. All I'm doing is operating this machine. The machine is doing all of the playing. So I got a blue. Blue tells me to take 2 pieces from the left column. So the left column is gone. And now it's your turn.
So I think I'm feeling relieved. If I take the top one, then the matchbox player has to take the last one and it will lose. So I'm going to take 1, please.
Okay, so Ben has taken 1. Now I have to find this matchbox here. So you can probably guess which colour beads are in this matchbox. It sounds like there's only 1 bead inside there.
It doesn't feel like it has a lot of choice yet.
It has picked a red. The red is to take the final piece from there. And the matchbox has lost the game.
Yay! Does that answer the question? Wait.
Currently, Ben Sparks is cleverer than some matchboxes.
Yeah.
But here comes the clever bit. So this is a machine that is to demonstrate how machine learning works, how simple machine learning works. And this is where we do the machine learning part of this demonstration, where I'm going to take the 3 beads it's used away. So because it lost the game, these 3 beads probably represent bad moves because they didn't lead to winning.
See.
So I'm going to put those back into the box of beads I've got here.
So it's like negative reinforcement.
So that's negative reinforcement.
Is that the right word for it? I don't know. I made that phrase up. But...
Yeah, so it's a thing called reinforcement learning. So we took the beads away when it lost. If it does win a game, we're going to give it some extra beads to kind of give it some positive reinforcement as well.
Oh, okay.
So now we can play another game. And we're going to see if in the next 10 minutes the machine can get clever enough that it's cleverer than Ben Sparks.
Right, so we should play a bit quicker.
Yes. So now I'm going to speed up the games a bit. So again, I find the first box. I get a purple, which tells me to take 3 from there. Ben's turn.
I'm worried now. I would take 1 from the middle.
1 from the middle. Okay, now I have to find that matchbox, which matches that. And The matchboxes say take 1 from the pile with 2 in. So that is that pile. Ben's turn.
Interesting. I'm breathing a sigh of relief. I'll take the middle one again.
Okay, and then the matchbox here is now, again, it's the one with 1 in, but there's no beads left, which means that the machine resigns. The machine says, I can't win, I give up. And so I take those 2 beads away. Ben has won 2 games, and we're going to reset and go again. So again, I shake the first box. Let's see what happens this time.
I'm drastically trying to think of my strategy here.
A red.
Okay.
That is 1 from that pile. Ben's turn.
I would like to take 2 on the left.
Okay, now I again need to look through the matchboxes to find this one. The machine says to take 1 from one of the piles. So there we go, Ben's turn.
I'm going to take 1 on the right.
And here we go. So the machine has a bead there. It takes a red bead, which means to take 1 from that pile. Ben's turn.
Oh yeah, I didn't want that, did I? Yeah, I'll take the last one and lose. Oh dear.
And what has just happened before everyone's eyes is we have just made some matchboxes become more intelligent than Ben Sparks.
So it won that game. So the beads that it used to win.
I just did that wrong, didn't I? Yeah, I got ahead of myself and I threw the beads away.
You got so excited that the bloody matchboxes beat me.
Yes. What I should have done is, because the machine has won, we're now going to do some positive reinforcement. So from the box of beads I've got here, I'm picking out lots of reds, and we're going to put 3 extra reds into each box. Because winning is really, really good. Like when we lost, we took away 1 bead because it was bad, but it might not have been terrible.
Right, there are lots of ways to lose, yeah.
Yeah, and it might have only made us make on 1 of the moves. But now, because it's 1, we're like, wow, that's incredible. Here, have 3 extras of each. So next time you play it, it is incredibly likely to try and do the same thing because it reckons it's found a way of beating Ben Sparks.
Yeah, I'm not convinced I was playing optimally. And it's also like a weird dilemma for me. Like if I play optimally, I basically teach it to play optimally because I'm not convinced I was playing optimally. It's weird putting yourself under pressure with these YouTube shows, you know.
Yes, and obviously maybe you can make mistakes against it and let it win by accident. But if you play enough games against it, it'll kind of learn different ways of winning.
That is amazing. And I feel a bit humbled that I've been beaten by a small bunch of boxes.
Yeah, and it's surprisingly quickly these things learn, because it's quite a small game and there is an optimal way of playing. It finds it quite quickly. But if I now move my camera upwards to what I was briefly showed earlier, you'll see behind these boxes I have a much larger pile of matchboxes. And this machine, which may be familiar to people who follow Matt Parker's channel quite closely, as it appeared in one of Matt's videos a while back, is a machine just like the one I've demonstrated that plays noughts and crosses. Look at that. No, that's not better.
Matt wrote about it in his book as well, is that right?
Oh, good question. I don't remember if it was in there or not. I think there was something else about me in his book that wasn't the matchboxes.
I'm just remembering other bits of your fame, Matt. Sorry.
Yeah. In fact, that was a worse thing, but let's not worry about that.
Sorry.
So what you can see here, there are 304 matchboxes, and this is a Menace, a machine called Menace, which stands for the Machine Educable Noughts and Crosses Engine, or some people would say the Matchbox Educable Noughts and Crosses Engine. I've seen it both ways. And if I pick up one of the boxes, you can see on the front of them, if it will focus, can you see there's a noughts and crosses
it's just coming into focus. The contrast is sorting itself out.
Yeah, the light is a bit much. I'm going to turn the light down a bit. That might help.
Less light. Too much light. There we go. Now I can see the grid
position on the front.
Yeah, I can see an X in the middle, an X in the bottom left, and then a circle top right and middle right. Yeah.
And what I've got over here is 304 matchboxes, which represent every possible position for player 1 in noughts and crosses.
Well, every possible arrangement of an X and an O, or lots of them in the grid, is there.
Is there in that pile somewhere? Yes. So
what about like 1X in the top right corner? Does it have a different box for 1X in the bottom left corner?
No, okay, yeah, good point. If I did that, there would be about 5 times the number of matchboxes. So obviously, if you rotate the noughts and crosses board, you're effectively playing the same game. Just like we saw when we were doing Nim,
Yeah, the
I
two piles
had
was
like
just two
this
piles.
matchbox would be the same as the one with a piece, a space, a piece. It doesn't matter where the pieces are. You can kind of reduce the number of boxes. But it has every different rotation and reflection. One of those will be in there, so you can play the game. So you play the game exactly the same way. You start noughts and crosses. The machine goes first. You find the current matchbox, take a bead out at random, and at the end of the game, if the machine wins, it gets extras. If the machine loses, it loses pieces. And if it's a draw, it wins pieces as well, because really it shouldn't be winning unless you play against an optimal. Unless you play
So
against
you
a
penalise
non-optimal
it for
human.
drawing as well.
No, you know, you encourage it for drawing.
Oh, you encourage it for drawing. Okay.
I may have said, yeah, you give it piece for drawing, because really you could expect the best it could do to be winning. But an interesting thing, going back to something you said earlier, is that you weren't sure if you were playing optimally.
Yeah.
And one interesting thing about the machine is if you sit and play against it for a few hours and play optimally, it will learn how to beat an optimal strategy. But if you then go back to it and play really badly, you'll find you get to matchboxes that have complete randomness in them still. So you can confuse the machine if it's not learned enough by doing something really unexpected.
So that's a really interesting point about when we do machine learning or train a machine on examples. The examples we pick are really important.
Yes, and you can get some very bad algorithms if you give it bad training data. Right. Just like with Menace, one time I did it at a science festival, it was a bit dodgy for a few hours because it played against some very young kids to start with, who were essentially playing at random, and it learned some really, really bad strategies that could beat players that weren't concentrating, but it wasn't playing very well.
So, but it needs to see people play optimally to learn how to sort of counter that, but it also needs to deal with people who just are a bit rubbish. And if it doesn't see them, it won't necessarily beat them.
Yes, so it needs to see a little bit of everything in order to get good, which is a difficult thing because you kind of, there's no point really doing, if you make a machine learning machine that has to see everything before it's good, that's a little bit useless because then you've seen everything and effectively tried everything. So you kind of have to find ways of extrapolating from what you've got in a good way. And this is what more complicated machine learning is, but this just kind of demonstrates the basic idea of trying things and reinforcing or punishing.
And it's the sort of thing that we could get a computer to do, but seeing it done without any wires kind of demystifies that, doesn't it? Like that's just a matchbox with some stuff in it.
Yeah, but it is a computer because it does exactly what a computer would do. But I've had a lot of people tell me it's definitely not a computer because it's got no wires, but it does. You can imagine each box replaced with kind of like a variable, and put it inside Python, and it would do exactly the same thing, and then they would believe it's a computer program.
That's brilliant, and I feel somewhat sort of accepting of the fact that a matchbox computer beat me at NIM, because actually I love the idea that machine learning does not need to be a machine as we think of it in some sort of like mechanical or electrical thing. It can be just something which gets reinforced by doing well.
Yes. Also, I gave it a huge advantage by picking a position where it should win on perfect strategy, because I had to give it a chance to show that it could learn.
I have to give it a chance against Ben Sparks.
Yeah.
The guy who's still awake at 1:20 in the morning and can't really remember.
Yeah, well, we've still got a lot of hours left. 20 hours left of the stream.
I'm dead impressed. I'm dead impressed with the NIM machine, as I was already impressed with the Noughts and Crosses Menace machine. I could ask lots more about your background as well before we leave, but I was under the impression there were some other things that you needed to tell us.
Yeah, so we've been doing tricks and treats today, and it's now Halloween. So happy
Halloween.
It
is Halloween.
So you've seen my trick, but now I have a really great treat for everyone.
Just pointing out, it's still Halloween here.
Yeah, is that a Menga
Sierpinski carpet?
Yeah, it's not Menga Smoke, it's not 3D.
I'm not hijacking your treat though, sorry.
That's funny. Yeah, so I've got a good treat for everyone. So anyone that knows me will probably know that I am quite often plugging this thing, Chalk Dust, a magazine for the mathematically curious.
It's an amazing magazine. That's why you should plug it all the time.
Yeah, so it's a magazine that I'm one of the editors of, and we've got a really great team behind the magazine that helps put it together. And every 6 months we release a new issue, and it's kind of full of articles about maths, puzzles, interesting things, some funny jokes, some less funny jokes, and it's just kind of, it's sort of like, it's serious about the maths, but it's not very serious about itself, is how Adam always puts it. It's kind of like interesting and entertaining, but it doesn't take itself too seriously, so you can also enjoy reading it.
It is the only mathematical magazine that I genuinely laugh out loud regularly at. I'm just going to put it out there.
Yeah, And so my treat for you today is avid readers will notice there hasn't been an issue for a while. So my treat is that issue 12 has actually just been surprise released on the website and is now available to read to everyone watching the stream.
Yay, Chalk Dust is out now.
Yeah, so if you go over to chalkdustmagazine.com, you can read the articles online or download a PDF or read it on issue. And hopefully everyone here will enjoy it.
I feel a bit guilty. I've been threatening to try and write something for Chalk Dust for a long time, and
Yeah, since about issue 2, I think.
regularly seem to get some abuse about not actually following through on that promise. Maybe I should write up my favorite magic tricks from this show.
That would actually be a really nice article. Yeah,
a nice thing. So
if you say that, I'm going to start hassling you again on Twitter every day until you write it.
Thanks. Maybe I shouldn't have said it. It's not like it's on record or gone out to a few thousand people watching.
No one's watching, are they? It's the middle of the night.
It's the middle of the night. There's no one watching from other countries here. That's a lie. Everyone's discussing what time it is in their country on YouTube. Can I read out a couple of comments that I've just seen on YouTube for you, Matt? By the way, they're still commenting when they should have been clicking on the Chalk Dust magazine link and going there. But people are saying, what happens if you have two machines and you play them against each other? They have sort of argued this out in the comments, but it's worth hearing your thoughts on this, Matt.
Yeah, so it's, in fact, there's a page on my website where you can play a simulation of Menace, and I have a thing called Menace 2 on there, which is Menace that plays as the second player. What you need to do there is you need to carefully set up Menace 2 to get the how many beads you take away and give it when it loses correct. But when I've tried them against each other, usually the machine that plays first wins.
Okay.
Because the machine that plays first always uses the first matchbox, which gets well trained, and then sends the second machine to a certain matchbox. And if it can make one of the second move matchboxes run out of beads, it has got a way of always making the second machine resign.
So that's because a lack of beads in the machine is an auto lose for any machine.
But I think actually that's mostly just because in noughts and crosses for player one, it's easier to draw. So the first machine finds ways of drawing quicker, whereas the second machine loses lots quickly and then often dies, I sometimes say, because if it runs out of beads, it dies because it's got no moves left it could possibly make. Like we saw my one for Nim resigned.
So that's another example of where the training data matters. If you train a Menace or a Matchbox machine learning thing on anything, then it will learn stuff. But if it's only playing against something else, which is also trying to learn stuff off it, it's not going to get into a very profitable loop, is what you're saying. Not necessarily, anyway.
Yes. So you have to get good train data and decide what your rewards and punishments are going to be to get a decent machine.
If we'd said at the beginning of the show that one of the best magic tricks in this hour and a half was going to be a Matchbox beating me at a simple game, I guess this is maybe what math is all about, is that things which feel impossible happen when you follow the consequences of simple decisions, and maybe that's what algorithms and learning about stuff is all about. I love the fact that it works with a Matchbox. When you're back, Matt, for everyone else watching, is the person I mentioned earlier, who I believe is staying up through the entire.
Stay up for the whole thing. Yeah, I did. I managed to accidentally wake up at 9 o'clock this morning trying to sleep all day to prepare, so it's already a challenge. But I figure we're organising this thing, so why not stay up and try and watch the whole thing?
And you are in front of camera as well as being behind the scenes again another time?
Yeah, so I am on camera again for the last half an hour, when I will be trying not to fall asleep in front of a very exciting celebrity guest.
There's a lot of people in the comments saying, is there a schedule of guests? And I think we've made a deliberate decision not to publish the schedule because this is a charity event. If we told you when Matt Parker was going to waste your time by just drawing random cards out of a pack, you'd have all inexplicably turned up to watch him, and we want to keep the surprises. So we are not releasing a schedule. Is that still correct, Matt?
That's still correct, yeah. And also if you just tune in for Matt Parker, you'd missed all the other amazing guests.
Indeed. Even people who are not internet famous can produce amazing magic tricks, and we have plenty of proof of that already. I'm just looking at who's coming next. I'm not going to say, but I am going to say that in the next three is someone who makes some of the most famous mathematical artistic objects that a lot of people in this sort of world of maths curiosities would queue up to see. So hang around for that. There are also two other excellent presenters alongside an excellent host who's also one of the organizers. Any other highlights that, without naming names, Matt, that you should say, the sneak preview, what should you look out for coming up?
That's a good test.
put you on it now.
One of the reasons I'm staying up for the whole thing is that I couldn't choose who to sleep through because there's so many good people. So if I watch the whole thing, I don't have to decide which are the least.
Or as an organizer, you didn't want to choose who to tell that you were going to sleep through them. So I understand.
Yeah. But yeah, I'd recommend everyone watch as much as possible and watch the rest on catch up because there's some really great people coming.
And there will be people you recognize from TV or recognize their voices from the radio or both, or books and all sorts of things, not to mention YouTube. Now, anything else we need to discuss, Matt? I did want to ask you a little bit about, you've told us a bit about your teaching background and then doing research mathematics. What happens for you next? Are you working for Rolls-Royce indefinitely? How does that work?
Well, yeah, so I'm working for Cambridge University and their funding just comes through Rolls-Royce. So I'm for another 2 years working in Cambridge. Then I will be applying for jobs.
So as a postdoc, your job is not sort of a long-term thing. That's not how it works.
Yeah, no. So for a postdoc, typically you do your PhD, and then for a postdoc, you do 1 or 2 year contracts at various places. So you kind of go somewhere, research with someone for a few years, and then move on somewhere else to kind of pick up some research experience, and then hopefully after 4 or 5 years, you get a permanent job somewhere.
I'm just aware that a lot of people watching who have interest in this sort of thing might be in the situation where they are still studying mathematics and want to know what happens next. And so you carried on studying for a bit in a sort of researchy kind of way, but then it ends up being more of a job, and then that comes to an end somehow.
Yeah, but yeah, it's a difficult life because whether you get another job at the end of it is very much down to luck. Because if the right person has funding at the right time, it can be quite easy to get a job. But if none of the right people have funding at the right time, you might find there's no jobs in your area available.
Right. And so while people are queuing up to get good mathematicians to solve problems like this, it's still a somewhat lottery about finding the money in the right place for the right project for the right person.
Yeah, but I've been lucky so far. So I've got a 3-year job here. So I've got another 2 years on that, and we'll see what happens after that.
Right. Any prospective employers, particularly in the matchbox trade, want to snap Matt up in 2 years' time?
Yes, please.
You heard it here first. Can you show us again the link to the Chalk Dust release? Because this is big news. If anyone is still up at 1:30 in the morning UK time, I hasten to add, then this is hot off the press, except for the whole metaphor not being valid because it's not been pressed.
But it will at some point be a physical magazine.
It will.
We'll
get the physical copies.
Because normally we get 2,000 copies delivered to UCL.
Yeah.
We all go in and collect them, but we can't even go into UCL yet. Like some people can go in 1 day a week. It's not really feasible. There's no events to give them out at, but soon there will be printed copies.
We will get our hands on the latest Chalk Dust Autumn 2020. You saw it here first. Matt, turn your camera on and give us a wave. Thank you so much for beating me, making a Matchbox beat me at NIM. I'm sure it would beat me at Nelson Crosses. You've been great. I can hear the applause from across the world for Matt Scroggs and his Matchbox machines. And I'm going to ask you to turn your video off so we get ready for the next presenter and the next host, in fact.